Hello students, this lecture is for 4th semester electrical engineering students. This is the lecture of subject electrical measurement and instrumentation. Today we are going to read about the topic types of torque involved in a measuring instrument. Let us start with the definition of torque. In order to ensure proper operation of indicating instruments, the following three torques are required. In order to ensure proper operation of an indicating instrument, the torques are required, namely deflecting torque, controlling torque, damping torque. एक इंडिकेटिंग मेजरिंग इंस्ट्रूमेंट को प्रॉपरली ऑपरेट करने के लिए 3 टाइप्स ऑफ टॉर्क्स आर नीडेड. द फर्स्ट वन इज डिफ्लेक्टिंग टॉर्क, सेकेंड वन इज कंट्रोलिंग टॉर्क एंड द थर्ड वन इज डैम्पिंग टॉर्क. Going with the deflecting torque. First we have to discuss deflecting torque. One important requirement in indicating instruments is the arrangement for producing or operating deflecting torque. Deflecting torque TD. We are representing deflecting torque with the symbol TD. When the instrument is connected in the circuit to measure the given electrical quantity. When an instrument is measuring, indicating instrument is connected in the circuit, we are to measure the electrical quantity, the deflecting torque is provided in the instrument. How the electrical quantity is measured with the help of the deflecting torque? This is achieved by utilizing the various effects of electric current or voltage. The deflecting torque causes the moving system to move from its zero position, and the deflecting torque is produced by utilizing one or more of the following effects of current and voltage. What are the types of effect? This table represents the types of instrument and its operate in which type of effects and suitable for which types of sources, and what are the instruments involved in this category. First, moving iron type instrument. Magnetic effect is utilized in moving iron type instrument, and it is suitable for DC and AC. Both DC and AC supply used for the both output as the DC and AC, and the instruments in this category are ammeters and voltmeters. Moving iron type instrument involves magnetic effect, works on the magnetic effect and produces deflecting torque, and it is suitable for both DC and AC instruments, and the ammeter and voltmeter comes under this category. Next, coming to the moving coil instruments. It uses the electrodynamic effect and it is applicable for DC machines only, and ammeter voltmeters are the instruments of this category. Then dynamo type instruments. It uses electrodynamic effects and it is used for both DC and AC supply. Then ammeter, voltmeter, wattmeter, and usually 4 wattmeter. Wattmeters comes under this category of instruments. Then last, induction type instruments. This works on the electromagnetic induction effect and it is applicable for AC supply only, and the instruments comes under this category are ammeter, voltmeter, wattmeter, energy meter, etc. These are the types of instruments and what are the effects involved in, and it is suitable for which type of supplies. That mainly we can say deflecting torque. Deflecting torque helps the deflecting torques causes the moving system to move from its zero position. Initially the instrument is at zero, the pointer is at zero, indicating pointer is at zero. Deflecting torque helps the pointer to deflect from its zero position. The role of deflecting torque is to help the causes the moving system to move from its zero position. Next coming controlling torque. Controlling torque, control word indicates that the power of control. It opposes the deflecting torque and increase with the deflection of the moving system. Controlling torques brings the pointer back to the zero when the deflecting torque is removed. Controlling torque is the part of the instrument which brings into play a force called controlling force. This force opposes the deflection force and increases with the increase in deflections of the moving systems. To limit its movement, the pointer is brought to rest at a position where the two opposing forces, that is deflection and controlling forces, are equal. Types of control system. The controlling torque is provided in the instrument by spring control method and gravity control method. The controlling torque always opposes the deflecting torque, and the role of controlling torque to increase the deflection of the moving system so that final position of the pointer on the scale will be according to the magnitude of an electrical quantity to be measured. The controlling torque brings the pointer back to zero when the deflecting torque is removed. The role of deflecting torque is to move the indicating pointer from the zero position, and the role of controlling torque is to get back the pointer to the zero position after deflecting torque is removed. If we are not provided the pointer, if we are not provided the controlling torque, then the pointer once deflected would not return to the zero position on removing the deflecting torque. It will always stay at the zero position and never come back to the initial position. It is stay on the reading the indicating or the electrical quantity value is measured at the which value is measured, it's the pointer will stay at that point and never come back to the zero position. This is the controlling torque in indicating instruments may be provided by two methods. One is spring control, another is gravity control. Let us first discuss about spring control. In spring control, this diagram shows the spring control of in spring control method of an measuring instrument. How the spring, this is the control spring connected here, and a balance weight is provided to counterbalance the weight of the machine. Let us discuss in detail about the spring control method. Spring control utilizes two spiral hairsprings of non-magnetic alloy such as phosphorus, bronze or beryllium copper. The springs are oppositely wound So when the moving system deflects, one spring winds up while the outer unwind. Thus, the controlling torque is produced by the combined torsion of spring. Since the torsional torque is proportional to the angle of twist, the controlling torque is directly proportional to the angular deflection of the pointer. Spring control method is the most common method providing controlling torque in an electrical instrument. A spiral hairspring made up of some non-magnetic material like phosphor bronze is attached to the moving system. Like phosphor bronze or beryllium copper is attached to the moving system of the instrument as shown in the figure. The control spring is attached to the control spring is attached to the moving system of the instrument. Next, spring also serve the additional purpose of the leading current. A spring helps to moving the system with the deflection of the pointer. The spring is twisted in the opposite direction. When the pointer will deflect, the spring is twisted in the opposite direction. This twist in the spring provides the controlling torque. As we have discussed, the controlling torque is always opposite deflecting torque. So when the spring starts to deflect, the pointer starts to deflect, the spring is twisted in the opposite direction and spring provides the controlling torque. Since the torsion torque of a spiral spring is proportional to the angle of twist, the controlling torque Tc, the controlling torque is denoted by Tc is directly proportional to the angle of deflection of the pointer, that is theta. Tc, here we can, Tc is directly proportional to theta. The pointer will come to the rest position when the controlling torque is equal to deflecting torque. The pointer will come to the rest when the position occur Tc equal to Td. Controlling torque is equal to deflecting torque. Therefore, we achieve Td equal to Tc. Then going to the next part of the discussion, in an instrument where the deflecting torque is uniform, spring control provides a uniform scale over the whole range. The balanced weight is attached to the counterbalanced, the weight of the pointer and the other moving parts. A balanced weight is, in the figure we have seen that a balanced weight is connected to counterbalance the weight of the pointer and the other moving parts of the instrument. To counterbalance the weight of the pointer and the other parts of the system. Next, coming to the gravity control method. In gravity control method, a small weight is attached to the moving system. A small weight is attached to the moving system, which provides necessary controlling torque. In the zero position of the pointer, the control weight hangs vertically downward and therefore provides no controlling torque. However, under the action of deflection torque, the pointer moves from zero position and control weight moves in opposite direction. Due to the gravity, the control weight would tend to come in original position and thus provides an opposing or controlling torque. That is, the pointer comes to rest at a position where controlling torque is equal to deflecting torque. In this method, controlling torque is proportional to the sine of angle of the deflection. Because in this method, controlling torque Tc is not directly proportional to the angle of declination theta, but it is proportional to sine theta. Therefore, gravity control instrument have non-uniform scale being crowded in beginning. In gravity control method, a small adjustable weight is attached to the moving system in such way that the deflection condition is produces restoring controlling torque, and the pointer comes to the rest of the position where Td equal to Tc. This is all about the gravity control method. This diagram shows the arrangement. This diagram shows the arrangement of a gravity control method. This is the pointer, and it is the non-uniform scale. There is a balanced weight is attached to the moving system which provides necessary controlling torque, and it is the spindle of the system. It is the control weight, and this is the pointer deflect through angle theta, and here pointer is at 0 to angle theta movement. This is all about the diagram of gravity control method. Then moving to the damping torque. Good. One is deflecting torque, controlling torque, then damping torque. Damping force is to damp the oscillations of the pointer before come to rest. A damping torque is produced by a damping or stopping force which acts on the moving system only when it is moving and always opposes its motion. Such a torque is necessary to bring the pointer to rest quickly. Such torque is necessary, damping torque is necessary to bring the pointer to rest quickly. If there is no damping torque, then the pointer will keep moving to and fro motion about its final deflection position for some time before coming to the rest due to the inertia of moving system. There are three types of damping instruments. One is critical damp, second is under damp, and over damp. Critical damp means pointer rises quickly to its final position without oscillation. Under damp means oscillations of the system will not be completely prevented, and over damp means in this the response of the system is slow and lethargic. The damping torque acts only when the pointer is in motion and always opposes the motion. The position of the pointer when stationary is therefore not affected by damping torque. The degree of damping decides the behavior of the moving system. Then this diagram shows the behavior of an damping source. If the instrument is under damped, this shows the graph of the deflection and time. Graph of the deflection with respect to time. However, if the degree of damping is adjusted to such a value that the pointer comes off to the correct reading quickly without oscillating about it, the instrument is said to be critically damped. If the instrument is under damped, the pointer will oscillate about the final position for some time before coming to rest. If it is under damped, and if the instrument is over damped, the pointer will become slow and lethargic. Over damp. And when we will set critically damp, if the degree of damping is adjustable to such a value that the pointer comes to the correct reading quickly without oscillating about it, the instrument is said to be critically damped. This is all about the behavior of the instrument. Next coming the methods of damping. What are the three methods of damping? Air friction or pneumatic damping, eddy current damping or electromagnetic damping, fluid friction damping is the three methods of damping of an instrument. This is all about the torques involved in a measuring indicating type of instruments.